your guide and mentor for organic chemistry, and we are going to talk about the structure of phenanthrene. As I've already mentioned that if we know the structure of phenanthrene and anthracene, we actually know the structure for any and every aromatic or polynuclear aromatic compound. So let us rewrite this time the structure of anthracene. As it is, you know the structure of anthracene, okay? Because you've seen it in my last video. Let us rewrite so that we can just take it as a 1 second trick to understand and write the structure of phenanthrene. Okay? Just before I rewrite, I will write the structures of anthracene and phenanthrene in front of you. See, this is my anthracene, which is nothing but 3 rings fused together, right? Whereas this is my phenanthrene, which is also nothing but 3 rings fused together, but in a crisscross fashion. Right? This is how my phenanthrene is. It is the same, but the rings are not like in a straight line, but 2 rings and the 3rd ring is in a crisscross fashion. So let us talk about the structure of anthracene. And quickly take it as a trick to study the structure of phenanthrene. We have already said this in our last video that anthracene has how many carbons? C14 and H10. You can just simply count and write also. Right? Total carbons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So you have C14 and H10. We have already said that all the carbons are sp2 hybridized. Right? Because they are double bonded. Anything which is double bonded is sp2 hybridized. Then all the carbon-carbon single bonds are because of sp2 overlap, and the carbon and hydrogen single bonds are because of sp2 and s overlap. Right? Then another thing is all the carbons, they contain a p orbital, which is like a shape of a dumbbell, which contain 1 electron each, and that is involved in the formation of double bonds, which is lying perpendicular, right? Whereas all the other carbons are lying on the plane, whereas the p orbitals are lying perpendicular like this, and they are in the formation of pi electron cloud. Total number of pi electrons, how many? 2, 4, 6, 8, 10, 12 and 14. Pi electrons are 14. And what does your Mr. Huckle say? He says that 4n plus 2 is equals to number of pi electrons. Right? यहाँ पर हमने value ली 3 because, not because there are 3 rings, because we have to take some whole number. So 4 into 3 plus 2 is nothing but 14. 14 is equals to 14. Hence, we said that anthracene is aromatic. Now, my dear friends, if I want to write the structure of phenanthrene, what do? I just write phenanthrene here. And I forget that I was talking about anthracene. I already knew anthracene, so we just revised anthracene. Now see, whatever I wrote for anthracene is applicable for phenanthrene also. All the total number of carbons are 14, hydrogens are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 carbons and 10 hydrogens. All the carbons are sp2 hybridized. All the carbon-carbon single bonds are sp2 overlap. All the carbon and hydrogen are sp2s overlap. Each carbon contains a p orbital which contains 1 electron. Total number of pi electrons 14. 4n plus 2 is obeying, that is Huckle's rules is obeying. So that is how simple it is. We just have to do nothing. Whatever we expected, we understood in anthracene, we just have to copy paste. We are under the structure of phenanthrene, right? We've already seen numbering of phenanthrene in other videos. Don't forget to subscribe this channel. Thank you.